Hi guys, welcome back to a new video in the Python series. So in this video, we're going to talk about functions and recursive functions. So what exactly is a function? So what happens is sometimes in your code, there is a certain set of instructions that you want to use multiple times, right? It could be anything. But to make your code more elegant and simpler to understand, what we do is we take these set of instructions and we put them aside, okay? We create a separate block and we call this block a function. And whenever we want to use these instructions, we'll just call the function. It will return the required output and we'll use that in our code, right? So that is what a function technically does. So what is the syntax for defining a function? So you define a function f and you put in a certain set of parameters, okay? So you give some parameters to the function and your function is going to work with these values, all right? Then you put a colon, then you have your body of the function and then you have a return statement. So what exactly does the return statement do? It will basically return whatever value you want the function to return, right? So it's not always necessary for a function to have a return statement. You can have like different functions where whatever you want to show as the output, you just put it there, all right? Okay, so this is what a function looks like. So I could define a very simple function. For example, define say, okay? And I put some s inside this and I'll just say print s, okay? That's it. This is a function, okay? So what this function basically does is it will give me whatever string s I send to it, okay? It could be a string, it could be an integer, whatever, but it's basically printing, okay? So this is just a more elegant way of using print. But let's see what happens when I go with say, and okay, let's run this. So the function is there, and if I say Shreyam, okay? So let's see what the output is. It will print Shreyam, that's it, okay? So I could put something else, okay? I could print hello, and it will return hello, okay? So this is what a function is doing. It's a very lame function, I know, but this is how it works. So to look at a few more examples, remember in the last video when we talked about different simple questions in Python, we had this concept of reversing a number multiple times, right? Whether it was a palindrome number or whatever it was, we used it multiple times. So I could basically use a function for reversing a number, right? So function, define a function reverse of n, and what this function does is, so you define s equal to 0, and then while n is greater than 0, what I'll do is a equal to a mod 10, a equal to n mod 10, s is equal to s star 10 plus a, and n equal to n double slash a, okay? Double slash 10. This is what the code was, right, for reversing a number. Now, once I come outside the while loop, I'll just return this value, okay? So return the value of s. Now, let's look at an example. Let's say I want to reverse the number 1023. So for that, what I'll do is I'll just print reverse 1023. Okay, let's go with rev instead of reverse. Reverse is a keyword technically, so let's go with rev. And let's run this. And if I run this, you'll see it printed the reverse of the number, right? So you got 32001, right? Okay, cool. Now, so why is this important for us? Because remember when we wrote a code for printing all the palindrome numbers between a certain range, so we had the code for reversing the number inside the loop, right? So sometimes it becomes very messy, okay? If you have complicated functions inside your loop itself, in case you get some errors or when you're trying to debug your program, it becomes difficult for you to understand like what exactly is wrong with the function, right? So it's better to segregate your different parts, okay? So for that, what we can do is, so if I use this reverse, the same function, I could go with for I in range, let's say 1 to 1000, okay? 1001. So this is basically going to print all the palindrome numbers in this range, all right? And what I do is, if I is equal to reverse of I print I, okay? And let's see what happens if I run this code. So as you can see, it prints all the palindrome numbers, right? I mean, single digit numbers are obviously palindromic numbers. Then you have 11, 22, 33, so on and so forth. Then you have 101, and so basically all the palindrome numbers between 1 and 1000, you print it, okay? So see, this is so much simpler to understand, right? If I had this code inside this, it would have become lengthier, more messy, right? So it becomes difficult. So that's why we have this idea of defining functions. So let's look at one more simple example. So remember when you were kids, you were taught how to calculate simple interest and compound interest, right? So let's write a function for that. So suppose I define a function, si, which is prt. And what this does is, it's basically going to calculate the amount, amount after simple interest on this principal with this rate for the certain amount of time. So what I want to return is, so I'll calculate the interest first. So in, okay, let's go with I. Interest is basically P times R times T divided by 100, and I want to return p plus the interest, okay? So this is the first one. Now I could define, so let's run this, fine. Let's write another function, which is basically the compound interest, okay? So I could define ci of the same thing, okay? So let's go with this. So let's call it ci, and this will return, what will this return? So this will return p times 1 plus r by 100 whole to the power t, right? So I'll put a power before this, so times power of this comma the time, okay? So this directly calculates my amount, right? Now let's write a menu-driven program where I input the principal. So p is equal to input. I'm just shorting it, but you can enter messages if you want, but let's just go with p equal to input, and then p is equal to int of p, and I'll do the same for r and t, okay? And also for t. So I've inputted my principal, my rate, and my time. Now I'll give the user a choice, okay? So I give the user a choice, let's call it C. So I'll say that if, let's say 1 for SI and 2 for compound interest, okay? Right, let's run this. Now, if C is equal to 1, I print SI of PRT. Okay, so remember the sequence in which you pass the parameters should be the same, like the order should be same inside the function as well as when you're calling the function, right? Otherwise you'll get like wrong answers. So I print this, else I'll just print CI of this, okay? So let's print the compound interest on this, and let's run this. This will be, say the principal is 100. Okay, let's make a slight change over here. So let's put this as a string, because you know that the default input is string. So if it doesn't match, if you just enter 1, it's actually going to go into the else thing, okay? So be careful about these little things. So if I enter 1000, enter 5, and then I enter 3 as my time, and if I calculate the simple interest, what will I get? So it turns out to be 1150, right? Let's try it again with the compound interest thing. So I mean 1000, again same thing, 5, 3, and if I enter 2, even though anything else is going to give you the compound interest in this program. So you can see it turns out to be 1157.625 something, right? So a simple program where you made things elegant, right? You ask the user for the choice, you calculate the simple interest and the compound interest, right? Okay. So the next thing now we'll talk about is recursive functions. So what exactly is a recursive function? So a recursive function is one where the function calls on itself to calculate the value, right? For example, you guys all know about the Fibonacci sequence, right? So how is it defined? So f1 equal to f2 equal to 1, and after this every nth Fibonacci number is the sum of the previous two, right? So it's the sum of fn minus 1 and fn minus 2, right? That's how you calculate the Fibonacci sequence. So this will come to the code for the Fibonacci sequence in a second, but let's look at something simpler. Let's say we want to find n factorial using a recursive function. So what I do is I define a function, let's call fact of n. Now what I'll do is I'll say if n is equal to 0 or n is equal to 1, then I'll return 1. Otherwise, actually not otherwise, if while n is greater than equal to 0, what I'll do is I'll just return the value of n times fact of n minus 1. And why does this thing work? Because we know that n factorial can always be written as n times n minus 1 factorial, right? So even if you don't know the value of n minus 1 factorial, what I'm doing is I'm just multiplying n and then asking the code itself to calculate the value of n minus 1 factorial. So let's run this code, and you can see if I print the value of, let's say, fact of 6, you can see it turns out to be 720, right? So if I look at it in two steps, okay, so the first step, when you're breaking down n factorial, you get n times fact of n minus 1, right? Now again, when the code is running for n minus 1, it will become what? N minus 1 times n minus 2 factorial. So after two steps, you get n and n minus 1 multiplied together times the factorial of n minus 2 factorial. And this process is going to continue until you reach the base case, which in this case is 0 or 1, right? So when you reach 0 or 1, it will return 1, right? So ultimately, in the final step, you'll get 1 times 2, so on and so forth, all the way till n, which is exactly the value of n factorial, right? So this is a simple function to calculate n factorial. Now coming to the Fibonacci thing. So define Fibo. And this is a function that calculates the value of the nth term of the Fibonacci sequence. So again, in this case, we need base values again, right? So if n is equal to 1 or n is equal to 2, what I'll do is I'll return 1. Otherwise, while n is greater than equal to 1, what I'll do is I'll just return Fibo n minus 1 plus Fibo of n minus 2, right? Okay, and this is it. As simple as this. It's a 4-line program. So in the base cases, it will return 1. Otherwise, it will ask the function to calculate the Fibonacci value of n minus 1 and the n minus 2th term of the Fibonacci sequence, and then it adds it together. So individually, they'll branch out, right? So one part of the code is just going to figure out what Fibonacci n minus 1 is. The other part is going to figure out what Fibo of n minus 2 is. So you guys know about the Fibonacci sequences. Let's write down the first couple of terms. So you'll have 1 and 1 followed by a 2, then a 3, then a 5, then 8, then 13, then you get 21, then you'll get 34, right? So these are the first 9 terms of the Fibonacci sequence. Let's see if this is what we get when we run this code. So for I in range, let's say 1 till 10, will print Fibo of I, okay? So this is calculating the first 9 terms, right? So if you run the code, you see this is exactly what we calculated, okay? So this is how Fibonacci sequence works in recursive functions, okay? So these are some very basic examples of recursion and for functions. You can use this in different programs, and we'll come up with a video soon where we look at some standard questions about these, okay? So functions and recursive functions, what kind of questions you might get in Python. We'll come to that very soon in our next video. So if you like this, do let us know in the comments and stay tuned for more such videos.